All right, everybody, we're going to take our notes on section 1.4, powers and exponents. Start with a little warm-up on this. You can see we've got some quick multiplication here, some with negative signs, some with positive signs. If we just go through relatively quickly, we can see that 2 times 2 is equal to 4. Just like number 2, negative 2 times 2 being equal to positive 4. However, once we get to 3 with 3 negative signs, we end up with a value of negative 8. 2 times 2 is 4, times 2 again is 8, and 3 negatives produce a negative. You can see 3 times 3 times 3 for 27, and then a couple of fractions that both have negatives in them and have a 2 at the top and a 3 at the bottom. So 2 times 2 is 4, 3 times 3 is 9. It's a fraction, and it will be, in this case, positive because of the 2 negatives. Now, what powers are going to do is it's going to simplify how much we have to write down. So the next page gives us our objective, and that is going to be to simplify expressions containing exponents. So we're going to go back and forth from a long form to a short form. Exponents make things a little bit shorter. So on our next page, it says here that we have a power, which is an expression written with an exponent and a base or a value of such expression. For example, 3 to the second. So a power, you can see, is something in the form of 3 to the second. Other examples could be something like 4 to the third, 5 to the 6th power, 2 to the 8th power, and so on. And you can see what they've listed right here. The base is the big number, and the exponent right up here is the little number in the upper right-hand corner. And what that means, instead of writing 3 times 3, 3 to the second power simplifies that. Now, I realize if there's only 2 numbers, it doesn't change a lot. However, if there's a whole string of them, that does simplify how much you have to write. So now if we go to the next page, we can see some terminology that comes up when doing exponents. When a number is raised to the second power, we call that squared. And you can see they put the letter S for side, and they're saying that this is the side being squared. When you go to the bottom example, you can see that they're talking about the third power, which is called cubed, and you can see that they take the side letter S and they raise it to the third power. Okay? Now, those are the only ones that have special names that we use on a daily basis, squared and cubed. After that, it should be 4th and 5th and 6th and so on. So here's an example. Write the power represented by the geometric model. So you can see that it's a cube and all of the side lengths of 5, so they would write this in short form as 5 raised to the third power, which if you multiply it out using your calculator, you would have 125 units, and I put a U to represent annual units, inches, feet, meters, units squared. So we go over to the next one. Here's a square that has 2 sides of 6, which can be written as 6 to the second power, or 6 squared, which if we were to simplify it, would become 36 units squared. Moving on to the next page, this one we will not be doing. So we will then quickly move over to the next page, which I think has some valuable information with what I was just mentioning. Here's the words, the multiplication, the power, and the value, a little chart they made. So you can see 3 to the first, and I think it's important every once in a while to actually show up here putting in the 1 like they did. That's 1, 3, 3 to the first, which you know to be 3. 3 to the second is 2 3s raised to the second power, and 3 times 3 makes 9. Don't forget, second power is called a square. We go down here to the third power, and we know that's a cube, and you can see 3, 3, 3 for 3 to the third power, making it 27 when you multiply it out. 3 to the fourth power, notice no special name, just going to go ahead and make it 3 to the fourth and 3 to the fifth. But a nice little chart to organize some of that work. Now let's go over here where you see a big caution. In this expression, we have a negative 5 raised to the second. In this problem, the 5 is the base, not the -5. The negative sign is not in the parentheses. In this expression, you can see a -2 to the second power. -2 is in the base because it's in the parentheses. Let's look at some examples of this. If I put -5 to the second, next to that I put in parentheses -5 to the second, and then I just do a plain old 5 to the second. Remember what squared means. It means 2 of the same thing. So the third one is 5 times 5. The middle one is -5 times -5. And the first one is 5 times 5 with a negative sitting out in front of it. So when you multiply these out, we're going to get a 25, putting the negative in front. Since we have 2 negatives in the second example, we get 25. And in the third example, they're both positive, so we're going to get a 25. So watch when I bring up the calculator. If I bring up the calculator, where we left off in class, you can see here, clearing this, if I put in -5 and I square it, whoops, clear, let's try that again, put this 2 in the box, -5 raised to the second, we get -25. But when I put parentheses around it like so, and then I raise it to the second power, notice the calculator produces a different answer, just like I showed. In the last example, 5 to the second is 25. Here's the benefits of using the calculator. You type it in exactly like you see it, it will produce the answer that you want. Okay? Our next page, you can see we've got some examples with some exponents. -6 to the third power, remember, is -6 times -6 times -6. And here's where I recommend, I don't know this offhand, go over, grab the calculator. Don't make it the whole screen though. Put it right here. It's got parentheses, let's use parentheses, open, -6, close, caret, 3, enter. Number is -216. B is -10 to the second. Remember, that's 10 times 10 with the negative out in front. 10 times 10 is 100 with the negative. If we go to the calculator, we type it in exactly like it looks. -10 caret to the second, -100. You can see the value that's coming out. The one at the bottom, when you get a fraction, this means to square the number at the top, square the number at the bottom. So 2 squared, 9 squared. 2 times 2 is 4, and 9 times 9 is 81. And I would do this in 2 parts. I would not type that one in to the calculator exactly, because it's going to give you a goofy decimal. And if you understand the math answer, yes, it will work. But for now, we don't know how to calculate. Next page, working backwards. Write each number as a power to the given base. They want us to produce 64 with base 8. So that's 8 to the what power? Gotta be a second. 8 times 8. So in letter B, 81 is what they want us to produce using -3 as the base. Well, I don't know. In this case, I don't know this one offhand, so I probably pull out the calculator and say, right, open, -3, close, caret to the third. -27, not enough. So now I would try open, -3, close, caret 4 of them. There it is, it's the 4th power. Using a little guess and check in the calculator to get that 4th power up there. Okay, moving over to the next page. Here's a set of the same thing. -5 raised to the third. Type it in our calculator. Produce a value. Since there's 3 negatives, it's going to have to be a negative when it's all said and done, 1.5. Moving over to the one hanging out on the side. Remember, that's 3 to the third over 4 to the third. 3 times 3 times 3 we just did, which was 27. And 4 to the third, oh, we just did that. 4 times 4, 16 times, oh, wait a minute. I better type it in, 4 to the third. Oh, it's just 4 to the third. Yeah, type it in anyway. 4. Caret 3 64, all right. So that will be 27 over, oops, undo that action, hit this button, 27 over 64. And the one at the bottom is negative 6 to the second, and the negative is not in the parentheses, so that's a 36, putting a negative out in front. Okay? This does not mean that the negative is going to occur more. And then the next 4 pages of this notes packet, we're not going to work on because they are repeats of what we just worked on. So that will get us started for you to go ahead and work on the book problems, and then continue moving with your powers and exponents, some edge elastic, some homework checks, and so on, getting ready for our quiz. All right? That is a 1.4 notes lesson.